I'm PARAMASIVAN from M1T1. Okay, today I'm going to explain you all about past year chapter 7.1 and 7.2. And the question I want to discuss and explain to you is question 16, 2019 and 2020. Okay, the first question is nitrous acid HNO2 is used to distinguish between primary, secondary and tertiary amines. At 25 degrees Celsius, an aqueous solution of 0.215 mole HNN2 is 4.0% dissociated. Okay, we need to answer for three questions. Okay, the first question will be write a balanced equation for the dissociation of HNO2 in water. So the key points will be write balanced equation for HNO2 in water. Okay, so the equation will be HNO2 aqueous plus H2O liquid reversible arrow NO2 minus aqueous plus H2O aqueous. Okay, the second question will be determine the acid dissociation constant Ka for HNO2. So the keyword for this question will be determine acid dissociation constant, which is Ka and for HNO2. Okay, so first of all we need to do an ice table. So the initial will be 0.215, which we get from the question, and the change will be negative x. The equilibrium will be the 0.215 minus x, and H2O is empty. The NO2 minus and H2O will be the same, which is initial will be 0, change will be plus x, equilibrium will be x. Okay, so next we will find the percent of dissociation. A equal to x over 0.215 times 100%. So the percent of dissociation is given in the question is 4.0. So equal to x 0.215 times 100%. So when you solve, you will get 8.6 times 10 power to negative 3. So when you convert, you will get 0.0086. And then you will be finding the Ka using the formula NO2 times H3O plus divide HNO2. So NO2 times H3O plus will be 0.086 power of 2, and HNO2 will be 0.215 minus 0.0086. The value we get here, the equilibrium of HNO2, and the value of x is 0.086. So when you calculate, you will get 3.58 times 10 power to negative 4. Okay, the third question is calculate the pH of the solution. So the keyword over here is calculate pH. So the pH, to find the pH, we will use the log formula. So negative log H3O plus, so negative log 0.086, we will get 2.07. Okay, let's see the second question. Calcium hydroxide CaOH2 is used to neutralize excess acidity in lakes and salts. Calculate the pH of 0.30 mCaOH2 solution. So the key points for the question given is calculate the pH and the 0.30 mCaOH2 solution. So we need to do a table to simple our work and understanding. So you just write out the equation, which is CaOH2 aqueous will be changed to Ca2 plus aqueous plus 2OH minus aqueous. So the initial will be 0.30 and the final will be 0. By the way, for the Ca2 plus, it's opposite, which is initially 0 and final will be 0.30, and the 2OH minus initial will be 0 and the final will be 0.60. Okay, now we will finding the POH using the formula negative log OH minus. So negative log, just substitute the value OH minus, which will be 0.60, and we will be getting 0.222. Then pH plus POH is equal to 14, as we all know. So to find the pH, we will be minus 14 minus POH. So the POH value we have found just now, which is 0.222. So 14 minus 0.222, we will get 13.78. So this will be the pH value. Okay, the third question will be, in a weak acid strong base titration, 25 ml of KOH solution is titrated with 21.45 ml of 0.10 m HCN to reach the equivalence point. Okay, this is a statement given. So the first question is, write a balanced chemical reaction equation for the titration. So the key point for this question is write balanced chemical reaction equation for the titration. So the equation will be KOH plus HCN will be changed to KCN plus H2O. Okay, the second question will be, calculate the concentration of KOH solution at the equivalence point. So the key point will be calculate concentration of KOH solution and equivalent point. So the concentration will be 0 m at the equivalence point. And the third question is, explain why potassium cyanide KCN is not a neutral salt using appropriate equation. So the keywords will be explain, KCN is not a neutral salt, and appropriate equations. So we need to use equations which is appropriate, and we need to explain the reason as well. Okay, first point will be, KCN undergoes complete dissociation in water to form potassium and cyanide ion. And the equation will be KCN to K plus aqueous and Cn minus aqueous. And the second point will be, cyanide ion is a strong conjugate base of hydrogen cyanide. The third point will be, cyanide ion undergoes hydrolysis, which react with water to form hydrogen cyanide and hydroxide ion. And the formula will be Cn minus aqueous plus H2O liquid reversible arrow HCN aqueous plus OH minus aqueous. And the last point will be, the formation of hydroxide ion causes the pH of the solution greater than 7. Therefore, potassium cyanide is a basic salt. And the last question for discussion today will be, suggest a suitable indicator for the titration. And the keyword is suggest suitable indicator. So the answer will be phenolphthalein. Hope you all understand the questions and answers, and hope you all get my points and all can answer the question as well. Thank you.
That's all for this video. Please do remember, subscribe, like and share. If you have any question, please don't hesitate to consult with your lecturers. Stay at home, stay safe. Bye.